So here we'll discuss the questions of haloalkanes and haloarenes. So in this unit, the first question given is the reason for the insoluble nature of alkyl halides in water is their covalent nature, their low polarity, their non-ability to form hydrogen bonding with water, their high reactivity. The correct answer is option C, their non-ability to form hydrogen bonding with water. So why it is so, we'll consider the reason. To form a hydrogen bond, the molecule should have HF or HN or OH bond. So if the molecule possesses any one of these three bonds, we say they form hydrogen bonding. But alkyl halides do not have it, hence they do not form hydrogen bonding with water. Next, question number 2, which is a correct increasing order of boiling points of the following compound. Compounds given are isobutane, bromobutane, chlorobutane, and butane. So here we see that these are derivatives of butane. One is chlorobromoido. So boiling point depends on molecular mass. Higher the molecular mass, higher is the boiling point. Iodine has higher mass than bromide than chloride. So if we consider, according to their molar mass, the molar mass of isobutane is greater than bromobutane than chlorobutane, and hence next is butane. Thus the increasing order. Whenever we write increasing order, we have to write it from lower to higher order. Means which is having the least boiling point and which is having the highest. So lower molar masses of butane will have lower boiling point. Higher molar masses of isobutane will have higher boiling point. So when we consider option 1, butane has lower boiling point than 1 chlorobutane, then 1 bromobutane, and then which is having lower boiling point than isobutane. Hence the correct answer is option A. So for second question, the correct answer is option A. Next, when we consider question number 3, which is the correct increasing order of boiling points of the following compounds. So here options given are 1 bromoethane, 1 bromopropane, 1 bromobutane, 1 bromobenzene. So these are also derivatives of bromide, where bromo is same but the parent chain changes. The parent chain here is ethane, propane, butane, benzene. Ethane has 2 carbon atom, propane has 3 carbon atom, butane has 4 carbon atom, benzene has 6 carbon atom. So as already discussed for the above example, greater the molecular mass, higher is the boiling point. Hence bromobenzene has higher boiling point, 1 bromoethane has lower boiling point. Increasing order means least to highest. So 1 bromoethane has lower boiling point than 1 bromopropane, then 1 bromobutane, and finally bromobenzene. And hence the correct answer for the given question would be among this option D, where we see 1 bromoethane lower than 1 bromopropane, then 1 bromobutane, and bromobenzene. So option D is the correct answer. Next, we'll consider question number 4. Which of the following does possess the highest boiling point? As already discussed for the previous question, higher the molar mass, higher is the boiling point. So higher boiling point would be for which of the following we'll consider: chloromethane, chloroethane, bromomethane, and iodomethane. Iodide has the highest molar mass and hence iodomethane has the highest boiling point. So the correct answer is option D for question number 4. Next, we'll go with question number 5. Which among the following isomeric alkyl halides have the least boiling point? The word isomeric means that they have same molecular formula but they differ in their structural arrangement. And here the structural arrangement which we see is they differ in the position of Br and branching we see. So remember that for straight chain alkyl halide the boiling point is higher and greater the branching, lower is the surface area, and lower the surface area, lower is the van der Waal forces of attraction, and lower the van der Waal forces of attraction, we say that the boiling point decreases. So although they have same molecular formula, the lowest boiling point will be considered for option D, which is having the highest branching. So the correct answer for question number 5 is option D, where we see that the branching is more and hence it becomes the correct answer. Next, question number 6. The number of possible isomers for the compound C2H3Cl2Br is. So we'll try to draw the isomers of it, which I have already drawn here. We'll consider them. So here, when you draw the three different isomeric structure, so here the three different isomeric structure for C2H3Cl2Br are 1 bromo 1 comma 1 dichloroethane, 1 bromo 2 comma 2 dichloroethane, and 1 bromo 1 comma 2 dichloroethane. So all these three are position isomers which are formed here. Other than this, no other isomers are possible. Hence the correct answer is it can form three isomers. So the correct answer for question number 6 is option B, that is 3. Next we'll consider question number 7. Alkyl halides are converted into alcohols by. So given options are addition, substitution, dehydrohalogenation and reduction. So alkyl halides means Rx should be converted to ROH. That means X should be removed and substituted by the nucleophile OH minus. Hence it is nothing but OH minus goes to the place of alkyl halide, X to the place of OH minus. It is nothing but nucleophilic substitution reaction. And among the options, the option given is substitution, that is option B, substitution reaction. Next is question number 8, the reaction. So here they have given RCH2Cl, that is alkyl chloride. So already as we had discussed, whenever an alkyl chloride reacts with NaI, that is sodium iodide, in the presence of dry acetone, it results in the formation of alkyl iodide, that is halogen exchange reaction. Iodide goes to the place of Cl, Cl to the place of iodide, or vice versa, resulting in the formation of alkyl iodide. And when alkyl iodides are formed, we call that reaction as Finkelstein reaction. So the option C given here is Finkelstein, and that is the correct answer. Next, if we consider question number 9, toluene reacts with a halogen in the presence of iron 3 chloride, giving ortho and para halo compounds. The reaction is. So here if we consider the reaction of toluene with halogen, that is, we'll take example as Cl2, X is equal to Cl2. Cl2 forms an electrophile Cl plus, which attacks toluene in the presence of iron 3 chloride and gives you a mixture of ortho and para product. And since Cl plus is attacking, we call it as electrophilic substitution reaction. So option B is the correct answer. Next we'll go with question number 10. Which reagent will you use for the following reaction? So here the reaction given is butane will give you the product as monohalobutane, isomers of monohalobutane, and this is possible with Cl2 in the presence of UV light, which takes place through a mechanism which we call it as free radical mechanism. So free radical mechanism will give you the product. Either way the question can be asked. Here they have asked you the reagent, or they may ask you even the mechanism. Next we'll consider question number 11. So in case of question number 11, monohalogen derivatives of alkene may be prepared by treating alcohols with. The first option is thionyl chloride. So we'll see the reaction. When alcohol reacts with thionyl chloride, it results in the formation of alkyl halide SO2 and HCl. So alkyl halide can be prepared. Phosphorus halide. So alcohol can react either with phosphorus trichloride or with phosphorus pentachloride and results in the formation of alkyl chloride. Similarly, hydrohaloacids react in the presence of anhydrous zinc chloride. That is, if you take HCl and zinc chloride, that is alcohol reacting with HCl or HX in the presence of zinc chloride, we get the product as alkyl halide. So we see that by all these three methods, we can prepare alkyl halide. Hence the correct answer is option D, any one of the above reagent. Next we'll go with question number 12. Now here in the question number 12, the question given is, so we'll see the question as well as structure here. Arrange the following compounds in the increasing order of their boiling point. So here if you see, there are 4 carbon atoms, 9 hydrogen atoms and 1 Br. Even the compound B is having 4 compound A and B both will see. B is having 4 carbon atom, then 9 hydrogen atom and 1 Br. Even the compound A is having 4 carbon atom, 9 hydrogen atom and 1 Br. So all these are same molecular formula, just they differ in their arrangement. Here it's a straight chain alkane, slight branching occurs and the branching extent increases. So as already discussed, as the extent of branching increases, boiling point decreases. Increasing order means lower to higher. So least boiling point is for C, next is for A and then it's for B, and this order is given in which option, we'll check it. So A is not correct because B is given first, B is also not correct, C. Yes, C, A and B, hence the correct answer is option C. Next we'll go with question number 13. In question number 13, it's given, in which of the following molecules carbon atom marked with asterisk is asymmetric? Asymmetric means chiral carbon, that is a carbon bonded to 4 different atoms or groups of atom. We call it as chiral carbon. Here if we see, it is bonded to 4 different atoms. Here also B is bonded to 4 different atoms. C is also bonded to 4 different atoms, that is groups of atom, and D has 2 H. So 2H are similar, so it's not a chiral carbon. So when you consider A is chiral, B also as well as C, these 3 are asymmetric or chiral carbon, and hence the correct answer is option B, A, B, C. Similarly, we'll go with the next question, question number 14. Which of the following is an example of vicinal dihalide? So vicinal dihalide means you have a carbon atom which is bonded, that is adjacent carbon atom having 2 halogen atom. So we'll try to write the structure of the following. So when we consider the first one, dichloromethane, carbon having 2 Cl and 1 atom bonded to it is hydrogen. Similarly, if you consider option B, it is 1, 2 dichloroethane, so this itself will modify Cl and remaining are hydrogen atoms. So you have Cl on adjacent carbon atom, so it's a vicinal dihalide. Next, ethylene chloride as well as allylic chloride. We'll check with these 2 examples as well. The ethylene chloride. Ethylene chloride can be represented as 2, ethylene means 2 carbon atoms are there and Cl is present on the same carbon atom. And if Cl is present on the same carbon atom, remaining all are hydrogen, we call it as gem dihalide. Adjacent carbon atom, vicinal dihalide, same carbon atom, gem dihalide. And allylic chloride means a sp2 hybridized carbon atom to which a sp3 hybridized carbon atom is attached, and to that if a halogen is attached, we call it as allyl chloride. So here this is also not a vicinal dihalide. So the correct answer is option B, 1, 2 dichloroethane. Next is question number 15. The position of Br in the compound in CH3CH double bond CHCBr CH3 twice can be classified as. So here if you see, you are having a sp2 hybridized carbon atom bonded to sp3 hybridized carbon atom to which an halogen atom is bonded. We say that it is an allylic carbon and hence the given halide is allyl halide. So correct answer is option A. Next is question number 16. Chlorobenzene is formed by reaction of chlorine with benzene in the presence of AlCl3. Which of the following species attack the benzene ring in this reaction? So here chlorobenzene, that is when it is formed by chlorine with benzene in the presence of AlCl3, it's an Friedel-Crafts alkylation reaction which proceeds through electrophilic substitution, and hence the correct answer is option B, Cl plus, because it's an electrophilic substitution reaction. Similarly, we'll go with the next question, question number 17. Ethylene chloride is an, so already as discussed in question number 14, it's a gem dihalide. Why? Because here if you consider, you are having the halogen, that is Cl, bonded to the same carbon atom, and hence we call it as a gem dihalide. So correct answer is option B. Next, question number 18. In question number 18, we see that the catalyst used during anti-Markovnikov addition of HBr to alkane is benzoyl peroxide. The reaction occurs in the presence of peroxide for an anti-Markovnikov addition. Similarly, we'll go with question number 19. Haloalkane in the presence of alcoholic KOH always undergo elimination reaction. So here it's based on Saitzef rule that it undergoes elimination reaction. Elimination dominates over substitution. But for aqueous KOH, it will undergo substitution reaction. Next, we'll go with question number 20. A mixture of 1 chloropropane and 2 chloropropane when reacting with alcoholic KOH gives. So, we'll try to write the reaction. It is related to the previous question, that is elimination reaction. So, if you take an example of 1 chloropropane and 2 chloropropane, both are beta elimination reactions. So, we'll try to write the example here. Beta elimination means hydrogen from beta carbon atom and halogen from alpha carbon atom is eliminated. So here 1 chloropropane, when it is made to react with alcoholic KOH, the resulting product would be CH3. So beta carbon, 1H is removed, double bond, and then next it becomes CH2, Cl is removed, that is from alpha carbon atom. Similarly, now if I would take 2 chloropropane. So for 2 chloropropane, Cl is removed from second, that is alpha carbon atom. Any one you choose as beta, you are going to get the same product, that is 1 propene. So correct answer is option A, 1 propene. Next question number 21. A primary alkyl halide would prefer to undergo. So here we'll see the order of reactivity for SN1 and SN2. So here option given are SN1 reaction. So order of reactivity would be tertiary is greater than secondary, secondary than primary alkyl halide. For SN2 it is primary, more reactive than secondary, then more reactive than tertiary. So the correct answer is option B, SN2 reaction. Next one, we'll go with question number 22. Which of the following alkyl halides will undergo SN1 reaction most readily? So the option given are all are tertiary halides with one as fluorine, chlorine, bromine and iodine. Remember, the distance between carbon and iodide is less, hence the bond can be easily broken. So we say that since this bond can be easily broken, option D is the correct answer. Next question, what is the correct IUPAC name of CH3, CH25, sorry C2H5, CH2Br? We'll try to write the proper structure of it. So CH3 bonded to a carbon atom, and to that carbon atom ethyl group is bonded, that is C2H5. It has an hydrogen atom as well as to it CH2 is also bonded and Br. So we'll try to write it more clearly here so that we would be able to find out the longest carbon chain. I'll write it once again. So once again when I write it separately here, we'll just write it clearly. CH3 bonded to C, which is bonded to ethyl. I'll write it as CH2 CH3 and then again CH2 Br. So according to the rules, you have to select the longest carbon chain. So when we select the longest carbon chain, we get here a carbon chain of 4 carbon atom. On first position you have Br and on second position you have methyl. So alphabetically Br comes first with 4 carbon atoms. So your correct IUPAC name would be 1-bromo 2-methyl butane, that is option C. Next, we will go with question number 24. Molecules whose mirror image is non-superimposable over them are known as chiral. Which of the following molecules is chiral in nature? So to understand it, we'll draw the structures of them. So structure of 2-bromobutane, we will represent it, and then we will identify a chiral carbon present here. Similarly, all the structures will draw 2-bromobutane, 1-bromobutane, as well as the structure of 2-bromopropane and 2-bromopropanol. All these four structures we will write, and then we'll find out a chiral carbon. So you should know what is a chiral carbon. A chiral carbon has 4 different atoms or groups of atoms bonded to it. If even two are similar, it becomes a chiral. So based on that, we'll find out what would be the correct answer? So here if you consider option A, already we have written the structure. Here if you see first carbon is achiral, but second carbon if you see here, we can have one CH3 group, one Br, one H and one CH2 HCH3. So it is a chiral carbon atom or asymmetric carbon, hence it is chiral in nature. Remaining two carbons are achiral, but one carbon is chiral here. In case of 1-bromobutane, all the carbons have similar group. In case of 2-bromopropane also, carbon atom has similar group. In case of 2-bromopropan 2, all carbon atom has two similar group. Hence they all are achiral. The one which is chiral is option A, 2-bromobutane. Next, we'll go with question number 25. So question number 25 is reaction of C6H5CH2Br, that is the reaction of benzylic halide with aqueous sodium hydroxide follows. Answer is SN2 mechanism. Why? Because in SN1 mechanism the nucleophilic attack is not easily possible. Next, if we go with the next one, what should be the correct IUPAC name for diethyl bromomethane? We'll try to write its structure and then name it accordingly by selecting the longest carbon chain as we have discussed for the previous example. So here this is the structure based on the name given. We'll write the longest carbon chain if you count the carbon atoms from any side left to right or from right to left. There are totally 5 carbon atoms with the position of Br on third carbon atom. Hence its IUPAC name would be 3-bromopentane. Why? Because there are 5 carbon atoms in a carbon chain and hence according to it the correct answer is option B, 3-bromopentane. We'll go with the next question. That is question number 27. Grignard's reagent is not prepared in aqueous medium but prepared in ether medium because it's insoluble in water. The reagent is highly reactive in ether. The reagent reacts with water. Yes, it's true. It reacts with water. The reagent becomes inactive in water. Actually, it is even reacting with moisture. Hence, the correct answer is option C. Reagent reacts with water. 28 question number. Which of the following factors do not favor SN1 mechanism? Strong nucleophile, polar solvent, low concentration of nucleophile, tertiary alkyl halide. So strong nucleophile is not a necessary condition for SN1 mechanism. Remaining three are required condition. Hence the correct answer is option A. Strong nucleophile would not favor SN1 mechanism. Next, we'll consider question number 29. During the course of SN1 reaction, the intermediate species formed is a carbocation in step 1, which is a slow step which we have already discussed in a previous video. Next we'll go with question number 30. Isopropyl chloride undergoes hydrolysis by, since it's a secondary alkyl halide based on the reaction condition, it may undergo both SN1 and SN2 mechanism. Thank you for watching.